So we are on hyperbolas in this lesson or this video. So last one, so what I've done is kind of set up a lot of the things that are common to the ellipses and parabolas, all the stuff we've been doing. So you might pause, just take a second to write down everything that's already been written in red, because I'll most likely be talking faster than you can write it as we go through it. But anyways, yeah, if you want to set it up, that's fine. But so we're on hyperbolas. What we have for our standard form looks very similar to ellipses. The difference is, the main difference in identifying it just from its standard form is that you have a minus between x squared and y squared term. Now, also notice you can have y squared first, y squared minus x squared. But the key is that's a minus, not a plus. If it was a plus, we would have an ellipse. A couple of things to note about hyperbolas, besides the standard form being a little bit different, is if the x squared term is over a squared, it'll open left and right. And something to note there, I should have said this first, the a squared term always comes first. In an ellipse, a squared is always the larger term. So if you had a 9 on the bottom and a 36 on the bottom, a was always the larger number. For a hyperbola, that's not true. For a hyperbola, the a squared is always the first term, no matter if it's the larger or smaller number. So with that said, if the x squared comes first, our hyperbola opens left and right. If the y squared term comes first, and therefore the y squared is over the a squared, then we have a hyperbola. It is a hyperbola that opens up and down like the ones on the left. So what I'm going to do is go through and identify some of those main characteristics like we've done before. I've just kind of set them up a little bit ahead of time. So as is standard for, I think, every other one of our conics, the center is at h comma k. So we can identify that from that standard form. So with the graphs like these here on the left, where the graph the hyperbola is open up and down, the vertices are as follows. So we have our h stays the same because we want to stay along the same as our center point, but the k moves, and the k moves by going k plus a and h comma k minus a. If our graph opens sideways, the hyperbolas, or the parabolas, if you will, the subsets of the hyperbola, open left and right, that's when we get to move our h's. So h minus a, and then keep our k the same, and h plus a, comma k. Is that right? Yep, good. All right, moving on. The foci, by the way, if we want to look at these on the graph, the vertex is just like a vertex of a parabola, because what we have is two parabolas that face away from each other. So the vertices do still refer, like a parabola, to the bottom of the bowl. So the vertex for the top and bottom, or left and right, are those 2 points. The foci, similar to parabolas, it's the same thing. It's the focus of each parabola. And for these, for hyperbolas, you have 2 foci because you have 2 parabolas. And those foci are at h comma k minus c, and k plus c. If your parabola goes sideways, we have, I'm sorry, if it opens, yeah, sideways, h minus c comma k, and h plus c comma k. So again, you notice that the up and down parts are moving, the y coordinates are moving on this, whereas hyperbolas that open sideways, you're moving your h's. But we kind of have to take a step back here and think, oh, well, what is c? And c, just like in an ellipse, remember we took this step back and we said, okay, c squared is equal to a squared plus b squared. Well, actually, if you notice on the ellipses, if you flip back to that, the equation actually read c squared equals a squared minus b squared. So please be careful. Hyperbolas, use the same format, c squared equals a squared, but it's plus b squared. So you would use the a and the b from the standard form and solve for c, the difference being that you are taking the a squared and b squared and you're adding them together. Now the asymptotes are this idea that I can draw these crisscross lines, and what happens is if I were to take these graphs and if I were to zoom out, say on Desmos or something, what you would see is that these parabolas do have these asymptotes, which, if we don't remember, an asymptote is a line that a graph will approach but never touch. And the equations for those two lines for which these parabolas approach but never touch are as follows. For graphs that open up and down, it is k minus or k plus the coefficient a over b, and then times x minus h. If your parabola opens sideways, very similar, except the only difference for the asymptotes for a sideways parabola, or hyperbola, sorry, is that your k minus and k plus take on a coefficient of b over a. So you take the reciprocals there. So those are your main characteristics. So if you were to go down to, say, some examples here, it says identify the vertices, foci, and asymptotes. What we would find, looks like my graph got cut off a little bit, so I'll at least do this. I will identify those main properties of this first example in the video, and then for timing purposes, I will just kind of spell them out here quick. So I better spell that out because I don't want that to be confused with the coefficient c. Center is at 2, 3. The vertex, or vertices, are at -1, 3, and 5, 3. Our foci I do not have the rounded number there, but it is 2 plus square root 13, 3, and 2 minus square root 13. Our asymptotes are y equals 3 plus and 3 minus, and that's 2/3. X minus 2. There you have it. So if I were to plot all of those, again, apologize, my graph doesn't quite work. I'll see if I can get it to work. But anyways, those are your main points. Those are the points you for sure need to identify on the graph. From there, it's your job to just simply sketch in, because it does say sketch. Remember, sketching is different from the graphing. Graphing, we want to be more accurate. Sketching, you just kind of get the general shape. But for sure, identify these points and the asymptotes for sure. And then from there, again, just kind of do your best to sketch in the hyperbolas. So let me see if I can't graph that. Okay, there you go. So I just took a second. I moved some stuff around. It didn't work perfectly with the labels. But anyways, what I did was I pointed the center at 2, 3, which is right here. I then also put the vertex, or vertices, which you can't quite see that one because my blue went right over top, but I put a dot there at 5, 3. My other one you can see, -1, 3. And honestly, from there, you can roughly guess that equation of that line there. But once you get those lines, you just, in blue, I just sketched in best I could what the hyperbolas look like. So there you go. I'm going to end it there. That's 10 minutes. That's plenty. Got the information. So I will see you in class.